Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith and we're in here at the shop. This is Steam Wagon Ho, part 11. Alright, in 10, we split the guide and we manufactured the flexible drill bit. Alright, now I can't wait to get in there and poke some holes in her. But we want to go ahead and put two flats on here so I can clamp the shell in place comfortable without any slipping and sliding. Alright, so we're going to put two flats on here. I have two parallels in here. And we're going to set it in there. And I'm going to take the shell mill. We're going to get that in there. We're going to knock those flats. And then we're going to grab the drill bit. We're going to go poke some holes in her. Alright, let's come in here close and let's get going. I think we're ready here. Alright, I'm just going to come down. I'm just going to touch that lightly and then back off of here. This is just a rough measurement there, but I'm going to set this at 0. And I'm going to go ahead and take 25 thousandths to start with. Alright, here we go. I'm just running it by hand. Remember, one of our split lines was just slightly off or a little bit off center. That one is the lesser of the two. This one here is a little bit greater. Okay, we're going to go ahead and we're going to take another 25. We're kind of watching the wall thickness of our two holes that are right in line with our flat. We are getting a slight little tiny bit of back cut, so we are pretty well trammed in. Kind of shows a sign of that. I'm just kind of, looking, observing what we have here. Okay, another 25. That's about 5/8. That's about half right there on the width. That's looking pretty good. That's looking pretty substantial for a flat. That one's not bad either. I think we're just going to take one more cut. One more 25 thousandths cut here. Alright, now we're going to run this one here a little slower. Alright, I'm happy with that amount of flat on both of those. Alright, we're going to go ahead and go over to our sanding block and we're just going to dress these off. Okay, I think I have everything here. The guide, our part, first let's put our part in. And, okay, we can rotate that around. And I want to lock this so that any pressure that we put on this thing, it won't accidentally come out of here and drop on the floor. That eliminates our spring action here. We can still rotate this around. All right, and like I said, we got our guide, and I'm going to put the guide back about 50 thousandths. Okay, let's bring you in close to this. Okay, with the guide on here, I'm just going to go ahead and set these a little bit here. We're pretty well touching there. We got a little tiny gap there, and I'm just going to go ahead and squeeze this together. Okay, both sides are touching. Remember, our split line was slightly off, so one side was a little tighter than that. It actually had to pop past center a little bit. Now, instead of running the vice grips on here, I think these do swing all the way around. So I'm going to put that on there like that. And I'm staring down, looking at the air gap. Looks like I'm good in there. Okay, machinist clamp can swing in there, no problem. All right. Now our guide is set and ready to go. There is no relationship or timing of these holes to the keyway, so I'm not going to worry about that. Now we need to go ahead and set up our drill. Now our drill will be able to come in through here, and we are close to the shaft, but our driver will be able to flex out from the shaft there itself. Alright, now we're going to drive it with our Tack Life rotary tool. So I got that laying on the bench here, and we're going to get this installed into the end here. And I believe all we got to do is rotate this around till we have our pinhole here. There we go. And take our wrench and tighten that up. Alright, now we have a power supply for our driver here. Alright, and we'll be able to feed it like that. Okay, I did bring over sulfur-based cutting oil, more so than anything else, to lubricate the bore as I'm poking it down through there. Okay, now this, I believe, has some speeds here, and we're going to turn it on, and we can see how that decides to fling out when I speed it up. And that's because of the natural curve that this cable has, and it's already off balance. But with it in the bore, now that we flung oil all over my pretzels, alright, and before I actually stick that in the hole there, we're going to go ahead and we're going to mark that hole, even though we'll be able to see it on the other side, but we're going to start on that one. Alright, here we go. We're going to put this in here, and I'm going to come at different angles and everything, and that fits in there pretty comfortable. Alright, now we're going to go ahead and turn this on. There we go. Yeah, she is drilling. When I put a little bit of pressure on it, you can hear that rotary tool bog down a little bit, but I don't think I don't need to actually bog it down. Now there's one thing that I'm not trying. I'm not trying to put a little bit of cutting oil right at the surface there, and I could probably even put a little bit of tapping fluid. My wire flex joint is sturdy enough to handle the push and the load. I went ahead and increased the power on the drill so I could put a little bit more pressure on here. She is making a tiny chip. Okay, I'm going to back it off, just see if I'm not clogging up this with chips. And I also want to just look at my tip here. And tip looks brand new. All right, and I am making chips. So let's clear out some of those chips, and let's stick her back in her. Maybe I ought to get a brush so I can clear out the chips a little bit more. And try a little bit of tapping fluid. It might be a little crisper. Well, okay, we should be getting close to going through. There we are, we're through. Okay, I'm going to go get my vacuum so I can suck this clean. Okay, I felt the nose of the tack life here, and it was getting a little warm. This is staying nice and cool. Now, instead of having it heading that way, coming back this way, and then coming here, I got one gradual swoop in the flex cable here, and we're going to see if that creates less drag and less draw from the driving the drill bit here. All right, now also what I did is this is just a 1/8 needle gun pin, and I went ahead and I stuck it in on this side here so I can kind of see the gap there, and then I put it over here on this other side here, and it looks it looks good. So I'm just kind of like checking the fit and stuff. So it won't be until we have several holes in there when I can run this in here and definitely say that everything is uniform and 100%, which I have no doubt that this will do that. All right, the other thing, I went ahead and I got some Tap Magic, and I want to try to run tapping fluid and see if that doesn't help cut it a little bit better. And I'm going to go ahead and I'm going to lay a rag down over the top of my center holder here. And also too, instead of the vacuum and sucking oil with my shop vac, I'm just going to use the air nozzle and clear it out when I need to, and a paintbrush to knock it out. I got a paintbrush here, and we can just knock those out as we go. All right, now I'm still going to initially dip this in the cutting oil because I like to lubricate the hole that we're guiding in. All right, I think I'm ready for the second hole. Okay, little lube, stick it in. All right, then we're going to turn on the, I'm on like between 2 and 3 on the rotary thing here now, but we're going to turn on the power. All right. If I hold it against there, it vibrates more. Okay, let's add a little bit of tapping fluid. Okay, I'm going to increase it. That seems to be the, let it have a little bit more power so that when you put the load on it, she does drill in there. going to clear it. Put a little fluid. Okay, here we go. It's almost when I give it enough pressure to almost stall, that's when she's cutting a big chip. Okay, through the second one. Okay, we're going to let the tack life cool down. Alright, I'm back out here this morning because I didn't finish it up yesterday. I took a little time off and had some all-you-can-eat sushi hand rolls with my best friend. So we came back out here this morning, but I did read through the comments this morning before I came out. And I wanted to hit some of the highlights of the comments there, and I enjoy the comments because you learn and teach through the process that we share here on YouTube, and sometimes all in one. I'm learning and teaching at the same time as well. Some of the highlights that are in the comments. One is this cable here twisted in the opposite direction as far as the force or the torque of the drive. Okay, now like Dremel and this tack life rotary tool only turns in one direction, so this wire is you're kind of stuck with this wire because this went down to the hardware store, and this one little piece right here was 2 cents. It's 19 cents a foot or so, and I used about an inch in here. So anyway, when I'm operating this drill, and I got you in here zoomed, you can see this thing grow, and it's growing because I'm pushing in, and the weight, centrifugal force, and my force pushing, you'll see that grow. Okay, and ideally, it would be nice if those wraps or windings would go in the other direction. You would get the optimum strength and less absorption. You would be stouter, I should say, firmer, but you could still flex, okay? And so far I'm not seeing any problem with this. I might actually have a little tiny bit. No, I just think it's the solder, the way that little cavity looks right there. So far, it's holding up great. We're on our fourth hole here. All right, now the other highlighted comment that I like is, and I refer to my solder, the 845, as general purpose. In some trades, it may not be general purpose, and I appreciate you guys jumping in that use all different kinds of solders and know the melting temperatures and what they're related for. The reason why I call this general purpose for me in the machining trade is I can do something like this, but I can also do something like this. And this is a carbide insert threading. This is a bar I made up, and I cut it down here, and once in a while I need to get in and thread an inside bore. So, and I've floated several of these on here because every once in a while it does take a shit, and you gotta get it off of there, and you gotta put another one on there. This is machined perfectly square, so when I clean it and I float that on there, it is nice and square to the holder. Okay, some of this gob, that's just because I've done it more than once, and over here as well. But that silver solder there can handle the amount of heat I put on that insert without floating off. And also, there's a lot of other tool bits that I braze up as well. So that's why I referred it to general purpose. Not the melting temperature or the amount of silver in there. It's just my go-to silver solder for my shop and what I use it for mostly. All right, now I've been playing with the speeds and everything else on the tack life and the progress of here, and I'm able to speed it up a little bit more and getting the tack life to go a little bit faster, and then creating the push. And when I'm going, you'll see this thing grow a little bit, but it hangs in there. All right, I'm going to coat it up the same thing as I did, and basically this is a lube for inside the hole. And then over here on this side here, I put in the tapping fluid. Okay, now I'm going to fire off the tool here at Tack Life. See that wire grow? And you can see the maximum bit, or the cutting of that drill bit, is on the maximum part of the push, and then I back off, let it clear. So it's like the tack life doesn't quite have the nuts to really pull the optimum at the load there. I mean, I can almost stall it out before it's actually starting to cut, but I am bringing out a chip. Okay, I think it's getting close to it. All right, we got it jammed. There we go. Okay, so we have what do we have? We have 10 more to go. Okay, there's our first failure. And I actually made a second one. This is the second failure. I tried to shorten it up, and by shortening it up and not giving it as much flex, made it blow out within a half a hole. And here's a view of that, kind of just like letting go. So anyway, I decided to go ahead and make it a little bit longer, take and solder it with less solder so the solder doesn't wick up into the wire as much, because where I saw it breaking on the first one was in there. And you know, when I kind of eyeballed that and was wondering what that little mark was, that was the first wire letting go, and then eventually it just like. So walking the talk, you get to see some of the failures as well as successes. All right, now we're going to continue on, and we're ready to pick this up again. All right, and we have a new flex in there, and this, I think, is just slightly longer than the original and less solder. So this is another test here. Now I didn't catch the first one going because I thought it's going so well, I'm just going to go ahead and do a few more holes and then get back to videoing, and then all of a sudden it took a dump on me. All right, so here we're going to get back at it, and hopefully I can eyeball this one here at a closer time before it lets go, so that I can catch it actually letting go on camera again. All right, and we'll turn on our motor. Okay. All right. I mean, it is working much. It seems to be working much better. Definitely better than the short leg there. It's holding its own. All right. I don't see any damage, so I'm going to inspect it after each hole. And as I get closer to wrapping this job up, I'll bring you back in whether this actually holds together or if it decides to let go. Hopefully, I can start catching it before it lets go, and I'm going to be watching it real close. And the failure usually starts in right at this area right here where I'm creating that flex. Now this one here does have a lot better flex than even our first one. Alright, it is just that little bit longer and a little less soldering into this section right here does let it flex a little bit better. So let's see how it does. Okay, I grabbed 2 C-clamps and hung a wire down here so I can hang my tack life up in the air here, because laying down on the bench it just didn't seem, I'm just trying to give myself the most freedom in here. And you can see every time I'm forcing the push in on there, I'm bringing a load on this. And in fact, I can stall this out. And on the bench, I was really feeling a lot of heat in the nose right here. So with it hanging here, it does have optimum ventilation through this thing here. And I've just done a couple holes, and we're gonna put the push on it. We're just gonna push right on through it what we can, and we're going to hope that this actually holds up and to the demand. We are pushing about the limits. So far this flex joint is working really well, and we're on our eighth hole now, and we just did 2 with this with no problem. And we're learning about the right speed here on this and the amount of pressure that we can jab in here. We're actually going through the hole a lot quicker. All right, so I'm going to run through one here, and I just get it lubed up here, and we get this one right here, kind of getting the right position here, and I'm going to put a little Tapmatic on that side there. All right, and I got to hold this steady and everything else so this doesn't whip around. That didn't help the second one. Okay, that was a phone call, but we're set up here on the next hole, and we thought we'd give you a good close-up of it drilling through that side, and at least you can still see this side here as well. So here we go. Okay, now I'm going to give this a little dab right in there. Okay, getting close. There we go. Okay, and this happens to be our very last hole, 12 of them. All right, and this joint is actually still holding, so it's telling us a lot. Well, I shouldn't say we don't have this hole drilled yet, right? Okay, and the tack life is it's warm, but it's not getting too hot to hold. All right, here we go. There we go. All right, we'll go ahead and get that cleaned up and take that out of the holder. Okay, let's go ahead and break loose our clamp, take off our jig. We'll blow that off with air. We're going to clean up this whole area and restart with another one here. And let's see, we got to break this loose here. and then we can break loose our piece, take it out. All right, now this is still stuck on here good, and what we do is we take the lead mallet and we tap it loose, but we're going to take the air nozzle and we're going to blow it, all the debris first, and we're going to lay it on over here. Okay, holding it over this, we tap that one. That one comes off easy. Then this one here, we just touch on the split line and it pops off. Okay, we're going to bring you in close here. I'm going to put it back in here so we can get a photo up. Okay, we're ready for our endurance test. Okay, we're going to be testing one, if the tack life has got the endurance to go ahead and go non-stop all the way around. Does the new flex joint, I say new, we drilled the last 4 or 5 holes. Actually, probably more than that. I think we did half of the holes, or close to half the holes on the other one with this extension here. And because we made it longer and reduced the amount of solder in it, so the solder doesn't flow up past these openings right here, and we tried to hold the heat way away from the wire, and we also didn't quench it to cool it, so we didn't mess up. I think that that's kind of the key of the whole thing. But we're gonna see if this can stand doing 12 consecutive holes at the same time. This is our first failure. This is our second failure. We shortened it up. We thought making it shorter would be sounder, but shorter made it flex harder, and it only lasted almost a whole hole, maybe a hole and a half. All right, little Tapmatic, our oil here, ready. Let's go. And I marked this one right here. I think right there, right there. We know it's on the split line, but visually from here, I can't see those openings all the time once we get debris in here. Okay. Yeah, I'm not going to blow it out or anything else. Okay, we're in there, and here we go. First hole. I think after the drill bit gets a little warm, it works pretty good. Okay. Cooking along. Everything's looking pretty good so far on this. And a little warm, not bad. Okay, coming up on our 6th hole, halfway there, just about. After this hole, we get two pretzels and a swig of our Pepsi. Intermission. All right. She's hot. Hot, hot, hot. You can sense that last little bit there at the end, and then just kind of really just kind of feather it really soft. You can get through there without it grabbing. I don't see any breaks or frays yet. It's actually going longer than I thought it would. That was almost a perfect ending there. Okay, 3 more. Okay, our very last one right here. Voila. All right. This thing's pretty hot. I wouldn't be able to hold that against my face, but my hands, my calloused hands can handle that. There's no temperature down here. It's all right up there, right in this area right there. All right. We were pushing on it. We honestly were pushing on it. All right. Tack Life is still alive, ready for the next job whenever it happens to come along. All right, and our third attempt of a flex joint here, even with the reverse spiral of the windings of the wire, it's done the job. All right, we were able to get that angle difference. You know, I really don't know how far we would be able to, you know, get that angle in there, but I was holding it down. You saw me here, and I was actually getting part of my hand against here so that I could really push on the end of this to get that action that I needed to. And this thing here, I could push and bury this in, and you know, you could see me, I could stall that, no problems. I don't know, it's first small rotary tool that I've ever had. All right, let's get this cleaned up, and then we're going to go ahead and do a final polish on the shaft over in the Rutland, and then they'll be ready to be packaged up, ready to send to Nathan. Well, Nathan, we got you a shaft for your Steam Wagon. All right, in fact, actually, you got 2 shafts for your Steam Wagon. I carried one along just in case I made a mistake, and well, that didn't happen. I don't know how, but that didn't happen. We did have a few mistakes on our little drill. In fact, actually, I was just picking up, bringing it in here, and kind of looking at it real close, and I was kind of flexing it as I turned. And there's a group of 7 on the drive side, and I could see the silver solders right there, and it actually broke right there. Next time I do this, I'm going to try soft solder, a little bit lower temperatures. I think the reason why this one lasts is much longer than the others, besides being a little bit longer and having to flex, less heat and not quenching it. I quenched the first two to cool them down so I can get going, because I'm not always that patient. All right, when Nathan gave me this project, and then I said it's going to take a little while, and it took a little bit longer than that little while. Nathan's project was the total motivation of getting that Rutland put into its condition now. And I wanted it in that condition because I needed to give Nathan shafts in this condition. So Nathan was the motivation to get the Rutland where it's at today, and I thank you very much, Nathan, for that. Nathan also asked, or he he says what he really wanted was my turn right stamp in on his axles, and that's what I've come in here to do. This is the last thing. I hit these with the wire, and you know they got a really nice luster and a little bit of the rust that is on, because you handle these, and right now is a humidity part of the year here, and anything that doesn't have a coat of oil on it will rust. And basically I had a little bit of fingerprints because of the acidities in the hands and stuff like that. We run into that. I wire wheeled it, brought in a really nice luster on these parts right now, and I'm going to soak them down with Zep 45, and I'm going to wrap them up in plastic, and I'm going to get them sent into the address you gave me there, Nate, the last address you gave me. And so let's I set up in the vise here, and I have two blocks underneath, two on the back and one here in the front, and that's to hold it rigid, because I just I want something stout, and I don't want to deform or shape or anything else on this. And this is gonna stamp fairly easy into this leaded stock here, and I've cleaned my stamp, and I should be able to get this aligned in here pretty good. And I'm just eyeballing the center that way and center this way here, and we're just gonna give it a one attempt stamp on each one. And there we go. All right. Excellent. Missing a little bit of the top of the T on that one, but you're not going to try to re-stamp these. All right, here we go on this one here, and we'll just have to try to have it standing up somewhat. Once you swing the hammer, you're committed. There we go. Both of them are pretty nice. This one here, I got a little bit more of the T at the top. All right, and they are stamped turn right 17. All right, even though we started this in what, 2000? Was it 2015? Nathan and I traded off some things to get this job done. Okay, so I'm going to send these to him, and he don't owe me a cent, except for his friendship. And he sent me some stuff that's going to let me get into 3D carving and on the plasma cam with a really nice water-cooled arbor. You've started seeing some of that stuff. We'll be getting into that. Now that we've got Nathan's job done, I can go full bore when I want to without a guilt trip. Because that does happen when you feel like you're not holding up to your end of the bargain sometimes. Anyway, I hope everybody enjoyed this project here and how we got here. All right, until next time, get her done.